Good evening, everyone. On behalf of SEDS Srihuna, I warmly welcome you all to SpaceTalk, our new webinar series where we explore latest advancements and ideas shaping future of space exploration. Today, we are kicking off session 1 with an exciting topic, reusable rockets. So it's my great pleasure to introduce our keynote speaker for today, Mr. Lahiru Udara. He is the lead engineer in operations at Robotic Assistance Devices and also served as the president of SEDS Mora during 2020 and 2021. Beyond his engineering work, he is a passionate space enthusiast and content creator at October Sky. With that, let's warmly welcome Mr. Lahiru Udara to share his insights on reusable rockets. Mr. Lahiru, the floor is yours.
Thank you very much for the warm welcome. I hope you guys can hear me.
Yes, we can.
Okay, thank you. So good evening, everyone. First of all, I would like to thank State Organizing Committee for inviting me to this webinar series. So without further ado, let's dive into the topic. So today's topic is reusable rockets 2.0. 2.0 means we are going to talk about reusable rocket past the what we have today in the world. So I think you all know about reusable rockets in the world right now. So if we go back a little, so there are three types of rockets in the world when we talk about reusability. So the reason I use the word launch vehicle instead of rocket is because there are a lot of rockets, and the one we are interested in here is launch vehicles. So I will give you a brief introduction. What is the difference between other rockets and launch vehicles? So rocket is basically any vehicle that has a rocket engine. So it is not limited to those rockets that go into the outer space. So we all know about missiles, and missiles have rocket engines. So technically, missile is also rocket. So that's why we have a specific name for rockets that go into outer space, which is launch vehicles. So even though we call rockets in general terms, the technical term is launch vehicles, rockets that are used for outer space exploration. So when it comes to reusability, there are three types of rocket. The first is expendable launch vehicles. Then we have partially reusable launch vehicles and fully reusable launch vehicles. So expendable launch vehicle means it is used only once. So, for example, this is Atlas V rocket built by United Launch Alliance company in America. So, if you are watching rocket launches, I think you have seen these rockets because this is one of the most famous rockets in the world. So if we take a look at the rocket, it has two stages. So this is the first stage. It's called Atlas V booster. Then it has the second stage called the Centaur, and it has solid rocket boosters attached to the first stage. This is the first stage engine. This is the second stage engine. Then at the top of the rocket, there's a spacecraft. It could be anything that is the payload we are sent into the outer space. So the job of the rocket is to send this spacecraft to desired orbit. So it could be a low Earth orbit, geosynchronous orbit, or it could go to the moon, Mars, or anywhere. The job of the rocket or job of the launch vehicle is to send this payload into the designated orbit. So the reason we call this expendable, because at the end of the launch, all of the rocket is expended. That means it is discarded. So during the launch, first solid rocket boosters are separated and they fall into the ocean. Then few minutes later, the fairings are separated. Fairings means these conical shaped pieces that is used to cover the payload until the rocket leaves the Earth orbit. So those are separated, and those also fell into the ocean. Then the first stage separates; it also fell into the ocean, and the second stage, or the Centaur in this case, goes to the final orbit with the payload because that's the one giving the final velocity for the payload. After that, multiple things could happen. Uh, if this satellite is going to a low Earth orbit, then the second stage remains in the low Earth orbit. If it has enough fuel, it can relight its engine and deorbit itself. That means uh, reduce the velocity and drop back into the Earth orbit, and it will be burned up during the re-entry. So it doesn't leave any space debris or space junk in low Earth orbit. But if the second stage is carrying the satellite to a higher orbit, let's say geosynchronous orbit, then the second stage doesn't have enough fuel to deorbit itself. So it probably remains in that orbit. So it count as a space junk or space debris. So we have a lot of space debris in a lot of Earth orbits. So it is becoming a concern. But as you can see, it is very difficult to deorbit the second stage if the payload is going to a higher orbit. So it is the reality, but that's the problem. So anyway, at the end of the launch, all parts of the rockets are discarded. So the launch vehicle is expendable. So you have to manufacture rockets per each launch. So at the end of the day, rocket launch prices are very high because you have to manufacture one rocket per each launch. So that's where the reusable rockets comes into the play. So let's start with the partially reusable launch vehicles. Partially means we are reusing only a part of the rocket, not the whole rocket. So this is the Falcon 9 I have used in this diagram. So Falcon 9 is a partially reusable launch vehicle. That means uh, first stage and fairings can be reused. So this rocket only has two stages. It doesn't have solid rocket boosters. So during the launch, first stage separates, and uh, it has some fuel remaining in its tank. So it doesn't burn fuel until the tanks are depleted. So it has some level, like 10% of fuel remaining at end of its first burn. So after separation, second stage continues into the orbit, and first stage flip around and comes back. So then it has to re-enter the Earth orbit. So it cannot just re-enter the Earth orbit because when something re-enter to the Earth orbit, the temperature around that region goes high because of the adiabatic heating. So it has to slow down a little bit. So just before re-entry, it starts three of its rocket engine and conduct what we call the entry burn. So it reduces some of its velocity before re-entering the atmosphere. After that, it can safely re-enter the Earth atmosphere, and then it falls back through the atmosphere. About 1 kilometers altitude, it relights its single engine, center engine, and reduce the final velocity and lands on a drone ship, which is stationed in the middle of the ocean. It could be Atlantic Ocean if you are launching towards the east side, or it could be Pacific Ocean if you are launching toward the west side. So on the second stage, fairings are separated once the second stage leaves the Earth orbit, and these are also recovered using parachutes. So these are very light structures because it is basically just a cone. So it will just fall back, deploy the parachute, and lands on the ocean. And there's a boat. It's going to reach them and pick them up. So fairings are easily recovered. Then the second stage continues to the final orbit, and it also remains in the final orbit, as I explained earlier, because it has the final velocity. If it is a low Earth orbit mission, it only needs very small amount of fuel to deorbit itself. But if it is going to a higher orbit like geostationary, it doesn't have enough fuel to deorbit itself. So it will remain in the orbit as a space debris. So the beauty of this partial reusable rockets is uh, it is very difficult to reuse the second stage because it has the final velocity that the payload needs. If it is going to a low Earth orbit, that is around 27,000 kilometers per hour. So, or 7.8 kilometers per second. So, if you enter the Earth orbit at that speed, it will generate a lot of heat, and you cannot basically do entry burn because there are so much velocity to be reduced. It is not like the first stage re-entry, because first stage separates around I think 10,000 kilometers per hour speed. So it has only a small amount of velocity that needs to be reduced before entering into the atmosphere. But second stage has a lot of velocity. So you need a dedicated heat shield on the second stage, and it is mass. Basically, it increased the mass of the second stage. So in the end, that reduced the performance of the second stage. So I think you all know rocket launch is a business. So the business is, if you are a rocket manufacturer, you are taking money from customers to launch their payloads into orbit. So that means you have to maximize the payload capacity of the rocket. So you need very efficient launch system, otherwise you won't be profitable. So that is the case. If you are going to reuse the second stage, you will add extra mass into the second stage that will reduce the performance or the payload capacity of the second stage. So that is the main problem if you are trying to reuse the second stage. But on the first stage, it is much easier because you are not reaching a very high speed when you separate the first stage. So you only need a small amount of fuel, and you don't need much of heat shieldings to protect from the heat when you are entering the atmosphere. So that's why this model is very economical, and that's why SpaceX has nailed it basically. Uh, so on the economy side, now you have a first stage and fairings back on Earth that can be reused. So you don't need to manufacture first stage and fairings over and over for each launch. You only have to manufacture second stage, which is a relatively small piece of the robot compared with the first stage. So all you have to do is get a good production line for the second stage. For example, on the Falcon 9 rockets, they have like 25 first stage that are like constantly used for launches. So some first stage have been used like up to 30 times, like 28, 29 times. So that's a very high number. But they have to manufacture second stage for every launch. So now they have like a very efficient production line that produces Falcon 9 second stage once every 3 days. So every 3 days, there's a Falcon 9 second stage coming out of the factory line. So you can just launch. So that is the problem SpaceX had to like solve before becoming a very high launch cadence company. But the story doesn't end here, because if we are launching a very light payload, let's say it is like the mass of the payload is very low, you don't need so much performance from the rocket. So that means you have a lot of propellant remaining. So what you can do is you can add another burn. So after the first stage separates, it flips around and fires its engine again to basically cancel out the forward momentum. So during the launch, it is like going this way, but it flips around and use its engines. So it will like diminish the forward velocity to 0. Then it will add velocity to this side. So using that, they can basically come back to the launch site. So it will bring down the cost another step, because now you don't need a drone ship in the ocean. You don't have to wait until the ship sail back into the port, and there's a port operation going on. When the drone ship reach the port, you have to use a crane to lift it up, then put it on the vehicle and transport back into your facility. So there's a lot of operation cost when you are doing the drone ship landings. But if you can do a return to launch site or RTLS kind of a mission, it becomes more economical, it becomes more profitable. So, but you can only do this if you have enough propellants to do a boost back burn. That's what this is called. So if you can do a boost back burn, come back to the launch site, the cost goes even lower. But payload has to be light. And holy grail of rockets is fully reusable rockets. That means we are using the both stage of the rocket. So I talked about use in the first stage. So this diagram is about Starship, you know very well about Starship, I think. So Starship basically two-stage rockets developed by SpaceX. This one is much more powerful and much bigger than the Falcon 9. Actually, this is the world largest rocket, actually. So first stage, do a RTLS or return to launch site. It has a boost back burn, it has a landing burn, but it doesn't have an entry burn, because Starship first stage is made out of steel compared to the Falcon 9 first stage, which is made out of aluminium. So steel can withstand a lot of heat. So it doesn't need the entry burn. It can just re-enter and endure the heatings it will get from the atmosphere. So that's why Starship doesn't have an entry burn, just a boost back burn to come back to the launch site and landing burn for landing. But the important thing is second stage. Second stage has to have heat shield because it is re-entering the atmosphere at like 27,000 kilometers per hour. So it will reach like I think 2000 degrees of Celsius and a lot of heat. So it has to have a very capable uh, heat shield for this task. And by doing so, the payload capacity of the launch system goes down. So we all know like the number that SpaceX always says is Starship can deliver 150 tons to orbit. That is by being reusable. So the actual capacity, if we are, let's say, expanding the Starship rocket, that means we are not trying to land the first stage, we are not trying to land the second stage. We are just using the first stage until the propellants are dried out, and we are using the second stage until the propellants are dried out. So, like Atlas V rocket. So, in that case, this rocket can send something into low Earth orbit like 250 to 300 tons. But when it is used as a reusable rocket, the performance comes down to like 150 tons. So that's the reason if you are trying to reuse the second stage, your performance of the rocket goes down. But if you have a large enough rocket, even with the penalty, uh, payload penalty, uh, you will still be good enough for doing a business. So right now, SpaceX has managed to land the second stage successfully, first stage successfully. So they are not trying to land the first stage this time. They are trying to catch the first stage using a giant robo arm. I think you have seen videos by now. So the reason is if you are adding landing legs to this massive first stage, it will add like hundreds of tons to the first stage dry mass, and you need this first stage as light as possible. So basically they are removing the landing legs and using robo arm to catch the first stage. On the second stage, they are trying to do the same. So far they have been able to land the second stage into the ocean at the desired landing spot. So in the future, I think next year they will try to get the Starship second stage back to the launch site and try to catch it with the robo arm. So they now have two launch pad. I think you have seen photos. I think if you are following the Starship progress, I think you have seen they have a two launch pad right now. So they will try to land both first stage and second stage back in the launch site probably early next year. So if they're successful, if they succeed doing that, it will be the first fully reusable orbital launch vehicle in the world. But the story doesn't end there because as I said, when you are trying to land the second stage, the mass of the second stage goes up because now it has to have a heat shield, it has to have some amount of propellant remaining in its tank for landing and so forth. So in Starship, the case is when it goes into low Earth orbit, basically all of its propellants are gone. So in other words, this is more like only for low Earth orbit transportation system, just like space shuttle. I, space shuttle, space shuttles can only go to the low Earth orbit. Goes to low Earth orbit, lands back on Earth again. It's reusable, but it cannot go beyond low Earth orbit. And Starship is basically the same. It only can go to the low Earth orbit with the propellant load. But SpaceX is trying to go around that limitation by orbital refueling. That means they are trying to refuel Starship in low Earth orbit. Otherwise, starships will be only good for low Earth orbit transportation. So if you want to go to the moon, Mars, as SpaceX market their rocket as a mass transportation system, they need to perfect the orbital refueling. So right now they don't have a solid plan for Mars missions, but they have been contracted by NASA for moon landings somewhere around 2027, 2028. So this is the Artemis 3 mission concept. Artemis 3 will be the first human landing on moon in this century. So that is slated for 2027, but it might go, it might be pushed back to 2028. Anyway, so NASA's plan is basically, so they are sending crew, 4 people with this Orion capsule to moon or lunar orbit using this rocket, that is the Space Launch System or SLS, which is a expendable launch vehicle. So all of this will be expended to send this small capsule to lunar orbit. And SpaceX task is to send a Starship to lunar orbit, then dock with the Orion spacecraft. Then the astronaut will transfer to the Starship. Then Starship will land on Moon, then comes back into the orbit. Again, dock with the Orion spacecraft. Astronaut transfer back into the Orion spacecraft, and they will come home on Orion spacecraft. So, using this expendable rocket, NASA can send the Orion spacecraft to lunar orbit in a single launch. But SpaceX cannot send a Starship to lunar orbit using a single rocket because it doesn't have fuel to go beyond low Earth orbit. So they need to have multiple orbital refueling before going to the moon. So their plan is first they will launch a big Starship or like a elongated Starship with more volume inside tanks. This is called propellant depot or fuel depot. So it is basically a storage. So this stretched Starship will be launched into the low Earth orbit. Then multiple Starships are launched to orbit, and each of them will dock with the depot and transfer its propellant to depot. So basically, they are trying to fill this uh, propellant depot Starship using these tanker depot, tanker Starships. So these Starships go up, fill this one a little, lands back on Earth. Another tanker goes up, fill this one, lands back on Earth, and so forth. It will need like 8, 10, maybe 12 tanker flights until this propellant depot is filled. Then at the end of this propellant refueling, orbital refueling, the Luna Starship will be launched, and this depot Starship will transfer all of its propellants to this Luna Starship, and it can goes to lunar orbit, then lands on the lunar surface and comes back up. So this will take months of operations before sending this one lunar Starship to lunar orbit, while this expendable rocket can send this spacecraft in a single launch. So this is one of the concerning thing about this concept, but it is what it is. Like, if you are trying to make a fully reusable rocket, it comes with its own problems. But in the end of the day, all of these launches won't be as expensive as this single rocket. That's the beauty of this system, because what you are doing is basically launching, landing. So your hardware, like, you don't need to manufacture rockets per each flight. You can just reuse a few first stage and few second stage. All you have to do is refill, and there would be some operational cost in these missions, but the manufacturing cost, material cost, hardware cost is next to zero. So these flights will be like very cheap to operate. So this one SLS rocket cost around, I think, $2 billion for a single launch. And SpaceX is trying to reduce cost of a single Starship rocket to like few millions. I don't know if they can reach it like in few years, but that's their end goal. uh, Even with like let's say if one Starship launch cost around 50 million, you can launch like 100 Starships before you reach the cost of SLS rocket. So that's why fully reusable rockets matters. Like, it is very cheap to operate. uh, so that's why everyone is trying to do that. So, but then SpaceX has to like comes up with the good operational procedures for like launching Starships in a small amount of time. Like, you need to refuel the depot in the Earth orbit as soon as possible. Uh, Only then you can send the lunar Starship. So if you are doing a Mars mission, that is also the same story, because you have to refuel that Starship, which is going to the Mars in low Earth orbit before it can restart its rocket engine. So I talked about the payload penalty earlier, but this is for Falcon 9, just for comparison. If you are doing if you are launching the Falcon 9 in a expendable configuration, that means you are not trying to reuse any part of the rocket, it can send around 23 tons to low Earth orbit. But if you are trying to land this first stage in a drone ship, the payload capacity drops to around 18 tons. And if you are doing a return to launch site kind of a mission, you can only launch 15 tons to low Earth orbit. In other words, if your payload mass is below 15 tons, you could do RTLS, and it will be very, very cheap mission for SpaceX. And this is for geosynchronous transorbit. If you are launching a geosynchronous communication, so in expendable configuration, it's 8.3 tons. It's a drone ship landing, it is 6 tons, and RTLS, it's 3.5 tons. So that is the payload penalty you are getting if you are trying to reuse a rocket. Okay, now let's move away from the SpaceX, because we have been talking about it since the beginning. This is Rocket Lab. So Rocket Lab is a New Zealand American joint company founded by Peter Beck. So they have a rocket called Electron. It is a small rocket, but it it has been proven that they can land this first stage back on Earth, but they are doing something different than SpaceX. So So what they're trying to do is basically uh, after the first stage separation, there won't be any boost back burn, entry burn, or landing burn. They are just trying to get the first stage intact through the atmospheric entry and then deploy a parachute and land on the ocean. Initially, they tried to catch the first stage while it is under parachute. Like their goal was to basically catch the first stage as it descends using the parachute using a helicopter. But it was proven that it is difficult to catch the first stage using a helicopter. So they dropped the idea, and now they are basically landing first stage directly into the ocean, and they can just pick it up using a ship. So this video is from one of their early trials. So in this one, they successfully catch the first stage using the helicopter, which is an impressive thing to do. So this view is from the helicopter. It has like a giant hook under the helicopter, so it can just uh, uh, attach to the parachute line. So yeah. So they successfully catch the first stage. You can see the parachute is being like deflated because it's now being lifted up by the helicopter. But helicopter had a problem in its engine or something, so they decided to release the first stage back. So the parachute again inflate and the first stage lands back in the ocean. But they successfully proven that they can do that. But they decided to just go with the ocean landing instead of trying to catch it with the helicopter. And then we have another company in America. This is Blue Origin. It was founded by Jeff Bezos, the founder of Amazon. He was once the richest man on the earth. Now it's Elon Musk, I think. So this company developed a kind of a very big rocket on its first try. So SpaceX started with Falcon 1, which is a very small rocket, then level up to Falcon 9, then level up to Falcon Heavy. Now they are in Starship. So Blue Origin started with a suborbital rocket called New Shepard. It is a suborbital rocket. That means it doesn't go to the orbit. And as their first orbital rocket, they just built this massive New Glenn rocket, which is a little bit smaller than the Starship. So they dream big, at least. So what they are trying to do is first, so they only have launched this rocket once, and they are trying to launch the second New Glenn rocket this month. I think they're trying to launch the second New Glenn rocket this month or next month. So initially, they are trying to land the first stage on its maiden launch. They tried to land the first stage, but it didn't work. But it's their first try. Uh, so they are trying again this the second time, but I think they will be successful soon. So as you can see, so this first stage has some interesting features. So we need to talk about this because these features are related to reusability. One thing is uh, it has these aerodynamic fins. Those are controlled when the first stage is returned into the earth. These are used for controlling, steer the first stage as it comes through the dense layers of the atmosphere. But these are very interesting because Falcon 9 Starship doesn't have these streaks. That's what they call these features, streaks. So streaks are basically like added surfaces for generating aerodynamic lift. So let me get a whiteboard again. Okay, I will just draw on this. So imagine the first stage is coming uh, like to this direction. So drone ship is kind of here. So it is trying to land here, and first stage is come here. So it has some aerodynamic fins here to steer the rocket. Um, so when it comes down, the atmosphere, there are molecules, like gas molecules everywhere. So it will create uh, atmospheric drag. So basically, it will try to create a force against the motion. So it basically reduce the speed of the first stage. So they don't need to use rocket engines for like reducing all the speed. So atmosphere reduce most of the speed, and rocket engines only has to reduce very small amount of velocity at the like during like last kilometer or two. So if you are coming straight down, only this circular phase, or this phase hits the atmosphere. Like this is the surface area hits the atmosphere. So so it generates a certain amount of drag force, which decrease the velocity. If you can like increase the surface area of the surface area you are facing the atmosphere, it will generate more drag force, hence it will reduce more velocity. So you only need very small amount of propellant for landing burn. So what they're trying to do is, they're as the first stage comes like in this direction, so this is the direction, but they are uh, angle in the first stage like this. So it's kind of, they are trying to fly the first stage. So now when you are coming in this direction, but with that kind of angle, so we call this angle the angle of attack. It's called alpha, angle of attack. So this now this surface is also exposed to the atmosphere. So that is a pretty big surface because it's very high. So now you have a lot of drag force working on the first stage. So your velocity goes down as you comes down to the surface. So Falcon 9 rocket also does this, Starship rocket also does this, but Blue Origin decided to add like small streaks on its sides. So it now you have more surface area on the first stage as you comes down. So this, when it comes down, it will like rotate 90 degrees. So these two surface will like work like aircraft wings on the first stage. So it will generate more drag force. uh, so their final velocity would be a lot less if you are like coming straight down with this circular phase uh, hitting the atmosphere. So that's why it has these big streaks on both sides of the first stage. So now you can see what I just explained. So as the first stage comes down, um, yeah, now you can see these streaks are aligned uh, in the horizontal direction, so they can just try to fly the first stage as it comes back down to the earth. So this is one of like in very interesting feature the New Glenn rocket has. So stay alert for their second launch around late this month or probably next month. I think they are not going to make it like in September, but yeah, I think they will try to launch in October. Yeah. Now the second stage continues as usual. It will drop its fairings, and these are different kind of payloads they can carry. So yeah. Okay. Then we have the neutron rocket. So I talked about the elect Rocket Lab company. So after the electron, they are trying to build the neutron. So they are going for the subatomic particles, as it seems. So neutron rocket is again first stage only. Only first stage is they are trying to reuse only the first stage. Um, uh, so far, they are like developing the rocket in a very good speed. They have manufactured tanks. Rocket engines are being tested right now. So a lot of progress they have made so far. So they are trying to launch this rocket next year. Uh, One of the interesting thing is you can see the rocket is black. So I told you like Falcon 9 is built out of aluminium. Most of rockets are built out of aluminium. Starship is made out of stainless steel, but this one is built with carbon composite or carbon fiber. So that's why it has this very distinct black color. Uh, the reason most rockets are made with metals instead of carbon composite because these are very expensive. But if you are trying to reuse the rocket, the hardware cost, the material cost comes down because you are just reusing already manufactured first stage. Um, Now here's the interesting part. So in Falcon 9 rocket, I told you like they are basically picking up fairing halves from the ocean using boats, but in neutron rocket, fairing is permanently attached to the first stage, so they won't be separated from the first stage or the second stage during the launch. So you can see how they are doing that. So what I want to like tell you is like each rocket is different. Each rocket has some kind of a different feature than the other. So that's what makes this like these are interesting. So going to yeah. So this is what they're trying to do. So they are like opening fairings like a kind of a flower, and the second stage completely the second stage is released from the rocket, and then uh, fairings are again closed, and the first stage goes back to the launch site, or could be a drone ship landing. So on the outside, it's going to be like it will be like the whole rocket comes back to the Earth, but the second stage was inside the rocket, and now it's been released. So it is a novel approach. It's different than what SpaceX has tried to do. So Rocket Lab company opened their Neutron launch pad early this month. Now they have a launch pad in America. Uh, I told you like the company was founded in like New Zealand. Electron is mostly launched from New Zealand, even though it has American launch pad. But Neutron rockets are launched only from America. They are not like they don't expect to launch these from New Zealand as they do with the Electron rocket. So these rocket engines are called Archimedes engine. Uh, if you go to like Rocket Lab social media pages, you can see they are testing these engines. So it is another kind of a reusable rocket. We will be able to see the first launch of Neutron rocket, hopefully next year. Okay, then another company in America. This is the Relativity Space. So they launch a single rocket since their formation. I think that was in 2023. I think so. It was called Terran 1, but after the first launch, they just dropped the idea of their rocket and moved to developing a much bigger and reusable rocket called Terran R. So it is also like a first stage reused rocket. They are not trying to reuse the second stage at this time. Now the difference of this company is they try to 3D print their rocket parts. So on the right side, you could see they are 3D printing the first stage dome structure. So that is basically the bottom part of the first stage, kind of here. And the interesting thing is you can see the shape. In other rocket, this would be like a circular, spherical section, the half kind of a half of the sphere. But here, since it was 3D printed, you could do custom shapes, more optimized shape. So they say this seashell kind of a design is much more lighter, and also it is much more stronger than just a half of a sphere as the dome, tank dome. So they basically 3D printed the Terran 1 rocket. Like most of its part, tanks, domes, rocket engines, and everything was 3D printed, and the rocket worked except for the second stage engine. But then they tried to do the same thing with the Terran R rocket, but it is a much more bigger rocket. It's a bigger rocket than the Terran 1, and they failed. So they realized somewhere around last year, I think, it is very slow and it is very expensive to 3D print a big tank. So even though they started with these cool videos with we are 3D printing a full rocket, they just dropped the idea. So it is not that economical for 3D printing a tank. So because tank is basically just a metal sheet formed into a circle. So basically it's basically a cylinder. So it is very cheap if you are using the conventional methods of making a tank. You just take a metal sheet and you bend it until it forms a circle. Then you have a cylindrical tank. So now they have decided they are not printing they are not 3D printing tanks, they are not 3D printing domes. they just 3D print rocket engines and other small and more complex parts, but they will use conventional methods for just to form tanks and domes. So yeah, so Terranar is also slated to fly next year. They are also making good progress now. They have like the CEO of the company has been like changed. So they are on a good path for the first launch next year. And so far I have been talking about partially reusable rockets. Like other than the Starship, everything was partially reusable. And there's another company in America who is building a fully reusable rocket. So they are called Stock Space. So this is their Nova rocket. And you can see, okay, this one is different. First stage was a conventional rocket, but second stage is completely different. So we can go back, yeah. So here you can see rocket engines are at the outer edge of this dome, uh, and they have a heat shield here. So on a Starship, heat shield is on the side, but in this rocket, heat shield at the bottom and rocket engines are at the circumference of the rocket second stage. So this is I would say this is not like a brand new concept, but it is kind of a novel concept when it comes to rockets. Sorry, yeah. So there are 30 small rocket engines on the outer rim of the second stage, and first stage comes back. Now this is the new normal, I guess, and it has kind of a payload fairings like neutron rocket head, but this is on second stage, and it do the deorbit burn to reduce its velocity, and then they re-enter the atmosphere as a capsule, and at the last part they just restart the engines, and the second stage also land back on the earth. And there's we have some new words. Actively cooled heat shield. What is that? So in Starship, there's heat shield is built out of ceramic tiles because that is the industry standard. Like everyone is making a heat shield with ceramics because ceramic is lightweight and it can withstand a lot of heat. But the metallic heat shield are not that popular. The reason is metals are heavy and metals cannot withstand so much heat like a ceramic does. But if you have active cooling on a metallic heat shield, that means they have heat shield built out of metal, probably steel because steel can withstand a lot of heat compared to aluminium, but even steel cannot withstand atmospheric re-entry alone. So that's why Starship has ceramic tiles. But Stock company is trying to actively cool this heat shield. That means they are pumping liquid hydrogen under the heat shield, like uh, so if you can like take a cut away, like let's say we cut this. So now they have rocket engines here, and they have a metal heat shield, and in this heat shield, there are small channels, small paths where they use a pump to send liquid hydrogen. So liquid hydrogen, it has like the temperature of liquid hydrogen is around minus 400, sorry, minus 253. I was thinking about Fahrenheit number. So minus 253 degrees of Celsius. So it is very, very cold. So as this very cold liquid goes through these channels, it will absorb the heat from the metal. So in the end, the metal won't melt by this intense heat because liquid hydrogen is taking away that heat, cooling the metallic structure. And yeah, that's what they meant by actively cooled metallic heat sheet. So since this is metal, the maintenance and repairs of this heat shield is very easy compared to the ceramic one, because ceramic heat shield are very brittle. It will it those break very easily. So this is the heat shield they are building. So you can see these metal, and you can see 30 rocket engines in the circumference of the yeah. And this is they are testing their second stage, and this is testing of the this second stage. So you can see rocket engines like 30 rocket engines in the outer circle. So this is uh, so Nova rocket is another fully reusable rocket which is slated to fly next year. I'm not sure if they can make it next year, but hopefully 2027, we will see another fully reusable rocket coming uh, alive. And as I told you, if you have a fully reusable rocket, you could do a lot of things. If you can make a system for orbital refueling, you could send these reusable second stages beyond Earth orbit. So just like Starship, if there's no orbital refueling, first Starships only goes to low Earth orbit. But with orbital refueling, it can go beyond. So Stock Space is also marketing that they can also do that thing. They can also refuel their Nova rocket second stage. Then they can go to higher orbit. Even they can go to the moon. And just like the lunar starship, their Nova spacecraft or the Nova second stage can land on moon. They say they can do that, but let's see. Or they could capture a orbital debris like a like old satellite, old rocket stage that is discarded in this orbit, and they can bring it back to Earth. So they can work as a orbital cleaning company. I don't know. So if you have a reusable second stage, and if you can refuel it in Earth orbit, you could do a lot of things. So right now, SpaceX is trying to do that using the Starship, and then we have Stock Space is trying to do that. And I want to remind that the CEO and the founder of Stock Space was actually a previous employee at SpaceX. I think SpaceX, or could be Blue Origin, but uh, the founder of the Stock Space has worked in, I think it is SpaceX, but I could be wrong. Uh, Maybe it's the Blue Origin, but he was an employee in one of those companies. Okay, that's all for America. Now go back to the, now let's go to the China, which is the second largest player in the space industry. So China doesn't like give out a lot of information like America does, but we have some level of information. So now China has a lot of private rocket companies building rockets. So leading company is Land Space. So they now have a rocket called CQ-2 launching rockets to orbit. That was the first rocket reach orbit using liquid methane as a propellant, not Starship. CQ-2 was the first rocket to reach orbit using liquid methane as the propellant. So CQ-3 is their equivalent of Falcon 9, basically. So right now they are like doing a lot of research and development to try to get an idea and experience about landing a rocket. So CQ-3 rocket is almost done. I think the first launch is supposed to be this year, probably within few months. So this video is like, I think last year. Uh, so this was basically a hopper. That means they are using this rocket stage as a landing test platform. So it has a single engine. You can see that engine here, but the ZQ-3 rocket has 9 of these engine. So this one goes up, comes back down. So they are experimenting and learning about rocket landing. So they have successfully done that. Um, and surprisingly, they release a lot of good videos about that. So they turned off the engine there, so they are free falling, and again they restart the rocket engine because they need to restart the engine when you are coming back to the Earth through the atmosphere. So they nailed it basically. So they have successfully hopped this research rocket stage 2 times now. So this video is their 10-kilometer try. So that rocket went to 10 kilometers and landed successfully. Now they are directly going to the launch of the ZQ-3 full rocket this year. Do I have a video photo? Yeah, so this is CQ-3 rocket. You can see it has 9 engines, just like Falcon 9. And you can see uh, it has grid fins here on the top of the first stage, just like Falcon 9. These grid fins are used for controlling the first stage as you comes down. So, and another company, this is Space Pioneer, and they have also built a copy of Falcon 9. It is called Tianlong 3. This rocket first stage successfully test fired a week ago in China, and they are also trying to launch this first rocket within few months. And another company called, sorry, I forgot to tell you, both the previously mentioned rocket ZQ-3 and Tianlong 3, they are trying to land and reuse the first stage. They are not trying to go for the second stage reusing yet. So both of them are basically copies of Falcon 9, I guess. So this is Kinetica 2. This was built by Cat Space, another Chinese company. So this looks like the Falcon Heavy, but the important thing is in Falcon Heavy, you could see these side boosters are separated and the first stage is separated and all 3 of them land separately. But in this rocket, these 3 parts remains as a single unit. So it will be separated from the second stage from here, and all these 3 cylinders comes back to the Earth as a single unit. So it is a different approach, I guess. And again, another Chinese company called uh, iSpace. So they are developing another reusable first stage for their Hyperbola 3 and then Hyperbola 3 Heavy in the future. So this is their hopping test. This was their hopper. So they also successfully did that. So if we've been like following SpaceX did this hopping test back in like 2012, 2013 period, and they landed the first stage in 2015. So now Chinese companies are doing this. So if they can follow the like same timeline SpaceX did, they will be able to land their first stage, hopefully around next year, because now they have seen how SpaceX does it and they know mistakes. They don't have to like repeat mistakes SpaceX did. So they would be, they should be able to land a first stage like very soon. Uh, Yeah. So I talked about Chinese private companies, but in China, that's also the government doing rocket business. Because these private companies were allowed to like launch rockets, only the state-owned rocket manufacturer was building and launching rockets. But since 2015, private companies are allowed to do that. That's when Space Pioneer, Land Space, Ice Space, then there are like Orion Space and all sort of private companies now in China launching rockets. Uh, but the government is the leading one. They have the biggest rocket compared to like these private companies, and they are developing a rocket like this. So you know what this is. This is another Chinese starship. So it is called Long March 9. You know, the government rockets are called Long March. They have Long March 2, 3, 4, a lot of rockets which are in use today. But the Long March 9 is their one of their next rocket. They are hoping to launch this in 2030. Let's see if they can like do that. But here you could see they could do 100 tons to low Earth orbit, kind of similar to SpaceX Starship. Then lunar trans orbit, that means they can send 50 tons to lunar orbit. And this is Mars trans orbit, so they can send 30 tons to Mars. So the diameter of the rocket is 10 meter, Starship is 9 meters, and the total mass is 6,000 ton. This is very similar to the Starship rocket, uh, and the performance are also similar to Starship rocket. So we can say this is Starship copy from China, but they are also building a one. So right now we only see Falcon 9 rockets landing like once every 3 days, but within I think 2 years we would be able to see uh, Nova rocket in America, Blue Origin's New Glenn, Terranar, and Neutron rockets like being very good reusable rockets in America. And in China, we would see ZQ3, Tianlong 3, Kinetica 2, and Long March 9 would like at the late 2020s, I guess, or early 2030s. But this decade, like from this decade, is the like the rise of these reusable rockets. So last decade we only had Falcon 9. Now we are going to see, I think, 10 reusable rockets that comes to the play. So with all of these reusable rocket, the major difference is the launch price. So before the Falcon 9 was a reusable rocket, the usual it took like 100 million per launch. If you want to send like a normal like few tons of spacecraft to low Earth orbit, it was around 100 to 200 million dollars. Now SpaceX is doing for the price of 62 million, but they are overcharging because they are the only rocket right now. They have the only rocket right now which is reusable, so they can charge as high they want under the price of the normal expendable rocket. So their internal cost per launch is around $15 million, but nobody can match that number because nobody has a similar rocket. So Atlas 5, it's expendable rocket, so it cost around 80 million to manufacture. So they are launching around 100 million price tag. SpaceX can like launch a rocket with the cost of 15 million with a similar performance because they are reusing the first stage. And but they are charging like 62 million because there's no competition for them to drop down the price until uh, I think next year. Probably there would be like 5, 6, 10 reusable rockets, and then SpaceX would have to reduce their launch price because the other reusable rockets would come at a similar cost, 10 to 20 million per cost. So then we could see like a massive drop in launch prices. Yeah, so that's about it. That's what I wanted to with you guys. I hope you learned a lot of new thing. Okay, we have some questions. Another one question is: it is believed that the Rumersel region has unusually low gravity. The idea once suggested by Sir Arthur C. Clarke, though it has not yet been scientifically proven. If validated, this could make Sri Lanka an advantageous location for rocket launches. Okay. Thing is, the gravity changes around the world. Yeah. But the difference of the gravity is very small. Like that is a small percentage reduction of the gravity. So if let's say SpaceX want to uh, build a launch pad here, so they have to transport the rocket through the ocean to Sri Lanka and launch, or they have to manufacture a rocket factory here to manufacture rockets. If in economical wise, it is not beneficial for them. And another thing, the most people like don't realize, rockets or the launch vehicles are essentially missiles with the peaceful payload, I think. So it has, but if you swap the payload, the spacecraft with the warhead, it is essentially a missile. So if you can build an orbital rocket, that means you have an intercontinental ballistic missile. So that means you could hit anywhere on Earth that using that orbital rocket as a missile. So in America, in China, Russia, and all these powerful countries has laws preventing people from other countries working in their rocket factories. So SpaceX can only hire American citizens. Blue Origin can hire only American citizen. NASA can hire only American citizen. Like all these American companies and government institute can only hire American citizen unless there's a very specific need, but that has to be like accepted from the Department of State or something, like very like it that person has to get military clearance. But like 99.9% people in those aerospace companies are American citizen. They don't hire any other citizens. So that means if you want to build a rocket factory in Sri Lanka or any other place, it is against American law, it is against Chinese law, it is against Russian law and everything. So, and from time to time, these rockets launch very classified payloads. That means secret satellites, probably like spy satellites, or we don't know, basically. We don't know. That's why it's classified information. Not like everyone in the rocket company knows about it. Like you have to get security clearance to like very high security clearance to be a part of that specific mission, because you will see that classified payload, you will see get information about that orbit this that satellite is going to. So very small number of people in rocket launching companies get that security clearance. So only that small group of people are dedicated for these kind of classified mission. So if you are launching rockets from another company, these kind of missions like won't be possible. That's why Rocket Lab has a dedicated launch pad in America, even though the rocket company was founded in New Zealand. So they have two launch pads in New Zealand and one in America, and they exclusively use that American launch pad for launching and American government security payloads. Like we don't know, like it's classified payloads, so most probably they are spy satellite, but they don't want to reveal the level of clearance of, like, let's say, resolution of images they have. So even though Sri Lanka has low gravity, which is a very small percentage of difference, there are a lot of factors that comes into rocket launch in locations, and the gravity is not one of them. Like I think that it is like they don't even consider, like, I mean, if they actually want to launch a rocket from a place where the gravity is low, they can launch from, top of the mountain, because it has a lower gravity in, like, if you go a few kilometers high in a mountain, you will have a reduced gravity because of the distance from the center of the earth. But you don't want to do that, because the level of reduction you would get from that gravity difference is not significant enough to make a difference in their decisions. So that's why they all want to build rocket launch pad in their respective countries. I think that might answer your question. Another question. As far as I know, the current liquid propellants do not generate enough thrust to go fast enough in the celestial standard years. What options we have with regards in this future? Yes, so right now we don't have like rockets propulsion that could like allow us to travel in between solar systems and galaxy and everything. We currently can go like within these planets we have. Now, one thing is nuclear rocket engines, which is practical. Like most countries are doing research about that, and it is not impossible. Like it is within laws of physics to build a nuclear rocket engines. Actually, America was building one engine until this current president cancelled the project. But yeah, they were building a nuclear rocket engine, which was like supposed to fly like 2028, 2029 kind of the period. But now that project has been cancelled or paused or something. It's not happening right now. But I think we could expect to see nuclear rocket engines within few decades. It will like it has more efficiency. I mean, on trust wise, trust is not a big issue. Efficiency is the main issue. Like how much impulse you could get from a 1 kilogram of propellant. If we have a lot of thrust, you would get a like big acceleration, and it is not bearable for humans or anything. So mm, efficiency matters along with the thrust. So nuclear rocket propulsion will increase the efficiency of the chemical rocket propulsion we have, but even with that it is not enough for like celestial travel. It doesn't allow us to go to like other galaxy, I guess. um, then we have solar sails, which is basically a large sail which deploys in space, and the photon from sun will provide a small thrust, but that thrust is continuous because you get sunlight all the time. So it will accelerate a spacecraft to a like very high speed, but it takes a lot of time for the acceleration because the thrust is very small. Uh, right now we have like few solar sails up in low Earth orbit, and they're trying different things with it. Solar sails is another option you could try to use for long distance travel. But ultimately, if you want like to go like very far, we need I don't know, warp drive or something like that. The rocket propulsion is not gonna cut it. Like it won't work. Uh, at least in this century. Like I don't see like any major breakthrough in these kind of areas in this decade. But in practicality, the greatest target right now we have is colonization of Moon and Mars. For doing that, we only need chemical rocket propulsion. Like SpaceX designed the Starship for colonizing Mars, so it has the capability to do so. Like nobody's trying to go to another solar system, nobody's trying to go to another star, another galaxy. Like I mean, in theory, it sounds wonderful, but in practicality, like it's a one-way trip, probably. So no one is like doing that stuff. So in reality, everybody is happy with what we have right now. But maybe someone will find a warp drive or something. I don't know. It's That's why there are researchers, I guess. Uh, how does Starship handle radiation in space? So radiation is like people talk like radiation is like a very big thing. Yeah, it is dangerous. Like it is dangerous. It affects our human body, but with some layers of metals and some materials, you could reduce the radiation you would get if you are doing like, let's say you are going to the Mars. So you are going in deep space for like 6 months. So you would face certain amount of radiation. You could reduce that by using some radiation protection materials, but you cannot like get the level of radiation to what we have on Earth. And that is a risk astronauts are willing to pay. They know they will get high exposure of radiation if they are going to Mars, Moon, or anywhere. They are leaving the protective magnetosphere of the Earth. So they know they will get that high level of radiation. So that is part of their job. Like you can't expect to like have uh, radiation level in surface level of the Earth in a starship in deep space. So they will face some kind of high level of radiation, but it is not lethal. Like going to Mars on a 6 month in a starship, you will not get a lethal dose of radiation. And a simple thing you could do is people are on the top of the starship, like in the nose cone. So you could simply turn the engine section towards the sun, which is the radiation source. So there would be multiple layers of metals like tank domes and other bulkheads in between, all act as a radiation shield to the people in the nose cone. So that is the simpler, like the most simple thing you can do. Just turn the engine section towards the sun. So you would get multiple layers of radiation shielding. And is there any chance to do astronautical engineering by learning BSc engineering? Uh, uh, I'm not sure what you meant by astronautical. I assume you meant aerospace, because astronomy is kind of a science, and if you want like rocket engineering, satellite engineering, that is the aerospace engineering part. Uh, Usually, in Sri Lanka, there's like not a single degree that covers all of the aerospace stuff, but mechanical engineering is like the closest thing you could get to a aerospace engineering degrees, uh, because like most of the things in rockets are like some kind of a extension of mechanical engineering aspects. So if you do a mechanical engineering degree, you would get the basic knowledge in a rocket, like all of these, like rocket engines, tanks, and everything. But it is not like a perfect solution, but it is, I say it's an alternative. So these are the questions right now I have. So thank you again for inviting me for this webinar series. Uh, and back to you, Charmini.
Yeah, so thank you very much, Mr. Lahiru, for that insightful session on reusable rockets. We really appreciate the time you took to share your knowledge and experiences with us. And thank you to everyone who joined Space Talk Session 1 today. So stay tuned for our upcoming sessions and see you soon.